All right, everyone. So today we're going to talk about a concept called absolute value. Some of you guys may be familiar with this, some of you may not, but basically what absolute value is it's a concept referring to a number's distance from zero on a number line. So for instance, I can draw a number line here to show you what I mean. We have 0 here, we have 2 here, -1 here. The absolute value we're looking for is essentially the number's distance from 0, right? And what that means is, well, the absolute value of this number here, take for instance this 2, is simply the number's distance from 0, which is in this case 2, right? Similarly, looking at -1 and 0, the number's distance from 0 in this case is simply 1, right? Because -1 is 1 away from 0, right? And so this is kind of how we're starting to define absolute value. The key thing to note here is that absolute value is always positive, right? So even in the case with this number -1, right, the distance from between -1 and 0 is still positive, and so we denote that as a positive number. And when we're discussing, a number, we're discussing the absolute value number. We use these double brackets around the number to express that number is, or that the absolute value of that number is what's being defined. So for some number x or for some expression x, it can be either way, and you would still be looking at the absolute value. So let's take a look at some examples here. So the first example is the absolute value of some number, or of the number -5, right? So if we look at -5 on a number line, right, and I can draw that up here. Well, we see -5 is right down here, and this is 0, right? And well, if we look at the distance from -5 to 0, well, we can see that's simply 5, right? We're essentially taking the positive value of that distance. And so the answer here is 5, right? We could also just simply take the positive value of -5. Since absolute value cannot be negative, that value is positive here. So similarly, if we look at the one on the bottom here, we see we're taking the absolute value of 5, right? And, looking at this, what's the distance between 5 and 0? Well, we can plot 5 up at the top here. And if we can look at that distance, we can see it's also 5, right? So this is also 5. So the absolute value of a negative or positive number of basically the same number when it's negative or positive, the absolute value will remain the same. So that's the key thing to know. So now we have two sort of more complicated examples. Let me just erase this. Where we take the absolute value of x, right, where x is any number, and we take the absolute value of x squared, where again, x is any number. So there's a few important things to consider here. So when we look at the absolute value of x, right, there's a few different ways this could go, right? What would the absolute value of x equal? Like, how could we represent the absolute value of x if we remove these bars? Like, what could we say the expression is equal to? Well, we have a few cases to consider here. So let's consider what would the absolute value of x be? Of course, since we know the factor that influences absolute value is sign, what would the absolute value of x be if x was a positive number, if x was a negative number, or if x was 0? Let's see what the absolute value would be in all those cases. So if x is greater than 0, then the absolute value of x is something, right? If x is less than 0, sorry, greater than or equal to 0, we can include 0 in that judgment, right? X is less than 0, then what is the absolute value of x? And yeah, that basically encompasses all our cases. Oh, sorry. So from there, we want to see, okay, what's happening to the absolute value when we change this? So when x is greater than or equal to 0, so that's a number like 0, 1, 2, 3, 4, or 5, right? That's a positive number. So therefore, the absolute value of x will simply equal x, right? Because when x is greater than 0, the absolute value of 5 does not change. It's already positive. It's 5 away from 0, it's 5. So the absolute value of x when x is positive is x, right? For any number. It's kind of a general rule here. But when x is less than 0, well, what happens to the absolute value of x? Well, we know a number like -5, right? Or -6, right? The absolute value of -5 is going to be 5, and the absolute value of -6 is going to be 6. So that x value, well, what's happening to it? Well, it's becoming negative, right? And so I know this part is a bit counterintuitive, but the absolute value of a negative number, right, is the negative of that number. So the absolute value of -5 is -5, which is 5. So if we were looking at any number x, right, this is the way we could define it. Now, let's take a look at this example here, x squared, the absolute value of x squared, which is a bit simpler in a way, because we have to remember some things about what happens when you square a number, right? So what is the absolute value of x squared? Well, again, it's just the number's distance from 0, but more importantly, what happens when we square a positive or a negative number? So 5 squared, right, is 25, right? And negative 5 squared is also 25. So what that tells me, right, is no matter if I square a positive or a negative number, and I'll erase this, it's still going to be positive, right? So this x squared here is always positive. So it's always greater than 0, right? And so because this is always greater than zero, well, what does that mean? That means that our absolute value isn't going to change at all. Since it's already positive, it's already a positive distance from 0, then this doesn't change at all. So this is simply equal to x squared, right? And so that's the difference between x and x squared. The x squared does not change when you take the absolute value of it, but the x does, because the x can be negative. So these were just a few examples to kind of introduce that topic here in a bit of a more demonstrative fashion. Great. So this is going to move a little more quickly here, but what I want to talk about is, well, what happened if we grabbed some values of absolute value functions? Just as kind of a brief introduction, what would happen if we grabbed these functions, right? So I'm assuming here that you know, if you're watching this video, you're sort of familiar with the idea of slope, right? You're familiar with the idea of graphing a line, like a line like y equals 1/2 x plus 1 or something like that, right? This is a very similar concept, but I'm assuming you're familiar with that before I get going with these two examples, right? So with that said, let's look at the first one. So we want to graph the function y equals the absolute value of x plus 2. Right? We want to see, okay, what will this look like when I graph it? And you know, if you recall here, this definition, right, of the absolute value of x, well, we know that when this x is less than 0, right, we have to take the negative of that x when we graph it, right? So we can start off by making a little table of values here, and then we can sort of, you know, see what that graph is going to look like. So we'll have our x and our y, right? Of course, when we plug in 0 for x, right, the absolute value of 0 is just 0, because 0 is essentially doesn't change its sign, right? 0 is always 0 distance from 0, right? It's kind of redundant, but it always is. And so our y is 2, right? When x is 0. So that seems normal. That's functioning like a normal y-intercept there. Our y is 2, we'll put a 2 there. And what happens when we plug in a 1? Well, when x is 1, y is 3, right? Because the absolute value of 1 is just 1 plus 2 is 3. So when x is 1, you can say y is 3. Now, what happens when we plug in a negative 1? Now, when x is negative 1, right, then we have our y is going to be the absolute value of negative 1 plus 2, right, which is also 3, right, because the absolute value of a negative number, right, in this case, becomes the negative of that negative number, which becomes positive, which stays 3. So our negative 1 is also 3, and I'll plot this point here. Sorry. These are all points on this graph here. And well, you know, we can continue plotting points for it, but since this is a linear function, we can already start to see a pattern here. The idea here with these absolute value functions is that, this isn't the best graph, is that these functions are essentially a reflection across this y-axis here, that when we have negative values, right, instead of this function behaving like a normal line, and for instance, going down this way, right, like a normal line with no absolute value would just look like would have negative y values. Because this you know, function is being sort of affected by this absolute value here, it actually ends up curving upward this way, because this absolute value is adding to, it doesn't decrease the y value, right? We always have an addition of x here instead of you know, the x value decreasing the y value over time. And so because of that, we see sort of this reflection or V shape across the y-axis instead of it going down like this, right? And you'll see that in the next example as well, but let's take a look at that one, because that one is going to sort of show us some different concepts, right? So again, we can start with the table. For this function, again, when x is 0, well, y is the absolute value of 0 minus 3, right? Which is the absolute value of negative 3, which is, of course, negative 3, which is 3. When x is 1, well, when x is 1, y is the absolute value of 1 minus 3, which is the absolute value of negative 2, and that's 2. And when x is -1, well, then y is the absolute value of -4, which in turn becomes -4, which becomes 4. So let's, knowing these points, just do a little bit of graphing. So when x is 0, well, y is 3. X is 1. The y is a 2. X is -1. The y is a 4. So plotting these 3 points here, right, we can start to see a pattern. But what we really need to notice here is, well, okay, what value makes x 0? Well, if I plug 3 into this equation, right, when x is 3, right, then y becomes 0, right? So when x is 3 here, y becomes 0. So this first stretch of the graph here, and connect this dot, is what's created by graphing these first couple points, right? We're getting some points here. Now I'm going to make another table for this to see what happens when we go further. We've hit 3. Plugging in x equals 3 makes the y value equal to 0. What happens when we plug in a 4 for x or a 5 for x, right? When you plug in a 4 for x, well, that outputs a 4, minus 3. The absolute value for minus 3 is just the absolute value of 1, which is 1. And plugging in a 5 gives us 5, the absolute value of 5 minus 3, which is just the absolute value of 2, which is 2, right? So 4, 5, 1, 2. We can see here that after we hit that value where the x becomes 0, right? Since the absolute value is always positive, it can't be negative. The graph, again, as we saw in example 1, starts to reflect upwards. And we start to see another V-shaped trend here. So that's sort of what I wanted to point out, is that eventually this graph will always hit a point where it can't go below a certain axis, whether that's the x-axis or the y-axis. Here, I mean, a point on the y-axis or a point on the x-axis here, and it'll eventually start to shift upwards again. And you can create these graphs, just by understanding the definition of absolute value and by plugging in points. You may start to see a couple trends here, like for example, in the first problem, this 2 is our y-intercept, and in this problem, right, this -3 signifies our x-intercept. But again, that requires some other knowledge of functions, and I'd rather not go into that. More here is just the goal is just to practice plugging in points and graphing these functions. Okay, so lastly, let's talk about some absolute value equations, right? And these are a bit complex. I don't expect everyone to get these on the first go, but basically, all we want to do is say, okay, given some equation, right? With absolute value or without absolute value, how can I find what x value makes this equation true, right? So in the example, the first equation, like I have the equation, the absolute value of x minus 2, right? Some x minus the value 2 is equal to 4. Well, how do I find what this x minus 2 could be? Well, I can start by saying this. Well, I'm going to say, okay, I'm going to call my x minus 2. I'm going to let the x minus 2 here, I'm going to call this some variable k, right? Because I'm just going to say this is some quantity, right? I'm going to call it k. So then I can rewrite this equation as the absolute value of k is equal to 4, right? And well, if you remember that definition of the absolute value of x, the absolute value of k, we're assuming k is some number, right? Then k, itself, right? It could either be positive or negative, right? K could be positive or negative, not the absolute value of k, but we don't know if k is positive or k is negative, right? So k itself could be a positive 4 or a negative 4. So this means, right, k could be positive 4 or negative 4, right? And that's because, well, the absolute value is always going to make it positive. So theoretically, it could also be a negative. I'm going to erase problem 2 here. I'm not sure if we're going to get to that one on this slide. But basically, all we're saying is, okay, k could be positive or negative, right? And that makes sense because if k is negative, then the absolute value of -4 equals 4, and the absolute value of 4 equals 4. So it's true in both cases, right? Great. So with that in mind, right, we just said let x minus 2 equal k. Well, we have sort of 2 separate equations we can solve. We have the equation, x minus 2, right, k equals 4, right, or x minus 2 equals -4, right? And this is just following saying, well, x minus 2 is that part we're trying to find. That's our absolute value, and it's going to either equal 4 or -4, because those are the two things that it can be, right, to make this equation true. And so now all we have to do is solve these little equations, these one-step equations separately, and we'll get two answers that actually solve this equation. So these absolute value equations, most of them at least have two solutions that make them true, right? One that's generally positive and one that's generally negative. So let's solve these two, this one and this one, and see what we get as an answer. So we can just do a +2 on this side, +2. So we'll get x is equal to 6. And on this side, we'll get x is equal to -2, or +2, +2. So our solution is x is equal to 6, or x is equal to -2. And let's check them to make sure they work. So again, back at our original equation, we can do a little bit of a check here. Well, if we plug in -6, well, we get 6 minus 2. The absolute value of 6 minus 2 equals 4, and that's true because the absolute value of 4 equals 4. And if we check the second solution, we get the absolute value of -2 minus 2 equals 4. And that's also true because the absolute value of -4 equals 4. And so again, the reason I had, I set this equal to k at the beginning is just to reiterate the fact that, well, k, if we're taking the absolute value of k, there's really only two possibilities. K could be positive or k could be negative, right? And so, based on those two possibilities, we can make two separate equations and find two solutions that satisfy the first equation, right? And so I understand this principle can be, a bit confusing at first, but we'll do another example and then we'll call it a day here, just to sort of solidify the process. So set the background here. Great. So I just make these on the fly, but we'll say twice the absolute value of x plus 3 equals 6. So twice the absolute value of this quantity equals 6. Well, the first thing we can do in solving this, right, is, well, we could just divide both sides by 2, right? Since twice this equals 6, well, then, therefore, if we divide by 2, this thing equals 3. So the absolute value of x plus 3, right, equals 3, right? And so again, in a similar fashion to the last part, we can say you don't have to do this. Let x plus 3, let's say it equals k, right? And the absolute value of k is equal to 3. And so then k could be -3 or 3. -3 or 3. And so therefore, since k is equal to x plus 3, then we know that x plus 3 is equal to is either -3 or x plus 3 equals 3. So then solving these, -3, x equals -6, or x equals simply 0, right? Because again, the absolute value, we're dealing with a random number. We don't know the sign of it. It could be either negative or positive since we're referring to the distance from 0, right? That negative sign may be necessary to convert the number to a positive thing if it's originally negative, right? And so again, let's check these solutions, right? So our original equation's up here. We say 2 times the absolute value of -6 plus 3 equals 6, and that's true because 2 times 3 equals 6. And again, if we look at our next solution, we get 2 times the absolute value of 0 plus 3 equals 6, and that's true because 2 times 3 also equals 6. So again, that's how you sort of solve a relatively simple absolute value equation, a part where you're trying to find out, okay, what part makes this equation too. So I hope this video was helpful. Again, this was kind of a brief overview of the topic. If you have any questions, please let me know. Please leave something in the comments. I will try to answer them. I will answer them if I can, most likely. And I will see you guys in the next video.